Welcome back. Today we will talking about optimal task solving and about transportation problem and about finding an optimal solution of transportational problem in Microsoft Excel application using solver add-in. So let's imagine, just for example, we have a problem like this. We have to deliver some portion of stuff, some quantity of stuff from storage to some, for example, some shop. Just for example, we can talking about medicines, and each portion of stuff, it's one quantity of medicine. And just for example, we have 4 storages, 4 warehouses with indexes A, B, C and D. And we have few shops. For example, we have 5 pharmacy shops with indexes 1, 2, 3, 4 and 5. And what credentials we have? For example, we have requirements how many pieces of medicine we have to deliver to each appropriate pharmacy shop. For example, we have to deliver 70 pieces of medicine to pharmacy shops number 2, 71 for pharmacy shops number 1, for 71 pieces for pharmacy shop number 2, and so on, and 74 pieces for pharmacy shop number 5. And in another hand, we have total availability. For example, in general we have 95 medicines in storage number A, and we have 80 medicines in general in warehouse with index number B, and so on. And we have total availability for each appropriate warehouse. And another values. These values represent us value of cost, of delivery cost. For example, to deliver 1 piece of medicine from storage number A to shop number 1, we have to spend 40 pieces of money. And for example, to deliver 1 piece of medicine from storage number B to shop number 3, we have to spend 40 monies, and so on. It's our input arguments, input values. Appropriate cost, demand for each appropriate shop, and availability for each appropriate storage. Let's insert few formulas. For example, we have to calculate total flow in for each pharmacy shop, like this. We can calculate a sum for each appropriate column. As you remember, each formula should be started according to Excel syntax, should be started from equal sign. After that, we have to append a title of formula, and in the brackets we can specify and input arguments. We can just pick up this range and click enter to apply. And we have to calculate this for each shops respectively. We can snap bottom right corner, drag and drop like this. Let's perform the same for each column. Let's calculate availability for each appropriate storage. Pick up appropriate range, appropriate column, click enter to apply, and propagate it down like this. Next move, we have to specify an objective cell, equal sign, some product. And pick up two ranges. Range number 1 argument separator semicolon. It could be a comma depending on a version of Excel. And pick up second input argument for some product function. Click enter to apply. And we have few helpers as well. It's total availability, sum of each appropriate warehouse availability, and total demand. It's a sum of these values. And our main goal is to calculate such values, calculate how many piece of medicine we have to deliver from each appropriate storage to each appropriate pharmacy shop with minimal cost. It's our main aim. And we have additional helper what calculate difference between total availability and total demand. And it's very important thing. We have two cases. Case number 1, it's current one. If this value is greater or equal than this one, we can just use solver and straightforward approach. So let's install solver if you still not perform it. Navigate to the file, options, add-ins, go, and use checkbox solver and click OK to install. After that we can find out it's in a main menu, data, solver. So let's apply some options. First of all, we have to pick up an objective cell. After that, we have to use a case with minimal solution to find. Let's specify and pick up output range. We have to change values in this range. We have to calculate how many pieces of stuff we have to deliver for each appropriate storage to each appropriate shop. Use this option, make unconstrained variables non-negative, and we can use simplex method. And after that we have to specify few constraints. First one, we can add, and let's consider this sum of this region all medicines delivered should be lower or equal than total demand. 360 in my case. And click OK to apply. Next one. Some of these values should be equal to this range. What does it mean? Total delivery for each pharmacy shops can't be greater than demand for each appropriate shop. Click OK to apply. And we can see tooltip. This range should be lower or equal than availability. Click OK to apply. After that, click Solve, and if optimal solution finded successfully, you can see appropriate note, and we can click OK to left these calculated values. So that's it. It's our optimal solution. But very important thing, there is case number 2. What happens if this value lower than this one? What does it mean? It's not enough in general. We cannot enough medicines to satisfy requirements. Total availability is lower than total demand. For example, it could be equal. It's okay. We can use this approach, case number 2. But if at least one single medicine not enough to satisfy total demand, we can use another approach. It's a case number 2. We have to add so-called dummy warehouse. Let's perform it. We can select whole entire line, entire row, right click, insert. It's so-called dummy warehouse. So, for example, let this storage store such value of medicines as a difference between these values, total availability and total demand. And for example, we have like this situation like this. This value will be calculated automatically. So if we add this dummy row, all credentials for all formulas moved, excepted this one. So we have to modify all these credentials. Let's drag it here. Let's drag it here. and let's delete previous solution and change erase and we have to add dummy warehouse for this table. Ctrl C and insert just values and specify delivery cost each time is 0, like this, and let's pick up correct diapason and click Enter. Next move, we have to modify and solver credentials. It's objective cell, minimal solution. Let's change output range from B3 to F7. And let's change this constriction from B3 to F7 like this. Okay, let's modify this constriction. Change and we don't need to modify, just check it out. From B8 to F8 equal B10 F10. Okay, and what about this one? Change. Yes, we have to modify from G3 to G7 lower equal than E3 I3 I7 and click OK. And left previous credentials, this one, and simplex method. And let's try to find some solution. Click to solve, and as you can see, there is no optimal solution found. Let's modify our file a little bit. Cancel, delete all this, and delete. And let's modify our file a little bit. Let's apply some minor modification. For example, first of all, let's consider availability for each storage should be greater or equal than total flow out calculated instantly. That's why we can modify it a little bit, this constriction. E3 E7 should be greater or equal than G3 G7 and click to solve. As you can see, optimal solution found it successfully, and click OK to apply. And it's our final solution. How many pieces of medicines we have to deliver for each appropriate storage to each appropriate shop. Okay, good luck, see you next time.